Hello, welcome back to this channel. I'm Ashura Sote and we're going with the data structure series. So last video we have seen the stack data structure and queue data structure, as well as we have also seen the algorithms for both of them. So in this video we'll see the linked list data structure. So linked list is a linear dynamic data structure. It's having the node-like structure, as you can see here, which contains the two fields. First one is the data and second one is a link. Data contains the element, means it contains the element, or we can say that the numbers or characters. And link contains the reference for the another node, or reference of next element, or reference of next node. It's stored into this particular link. Okay, so first node is called as head, last node is called as tail, and obviously as it is last node means it doesn't have the like link for the next node, its next node, because it is only the last node. So it contains a null as its last node in the link reference or link field. So actually the linked list is doing the same work that works done by the array actually. So what is the need of the linked list then? Because the array contains the some limitations. So the first limitation is like the size of the array must be known in advance. Okay, so we need to define the size before using the array first. Okay, then increasing the size of the array is a time taking process. Okay, so we cannot increase the size at the runtimes, means the size should be fixed, okay, before running it. Okay, then all the elements in the array need to be contiguous store, means we cannot store the element in non-contiguous or a scattered manner. Okay, because the array is a static linear static data structure, so we cannot store it in uncontiguous or non-contiguous manner. Then these much limitations are there in the array, and the list is overcome these above the particular limitation, means it's allocate the dynamic memory as it is a linear dynamic data structure. Then all the nodes of the linked list are in a non-contiguously stored, because means we can store our element, first element at the top and last element at the bottom, and afterwards we can connect, means we can uh, connect it reference by using the link field, as we have seen in previous slide. And sizing is no longer a problem, since we do not need to define its size, means here we need not define the size of the linked list at the time of the declaration. List grows as per the program demand and limited to the available memory space. So because of the problem of these particular array, we require the list, because list is overcome this above problem. There are mainly three types of linked lists actually: single linked list, double linked list, and circular linked list. Actually, the circular linked list having the two part, that is singly circular and doubly circular. I have mentioned here means it's separately, but it's come under this circular linked list only. That is singly linked list, singly circular, and doubly circular. So let's see one by one. So single linked list, as the name suggests, each node has a data and a pointer to the next node. Means it's having only single pointer, and it's actually very simple to implement. So as you can see in the slide, that means it's having the only single connection between the nodes. Okay, means it's having the two field, that is data, and the next field means it's nothing but the reference field. So where we are referring the other node into our no into our this field. Okay. Now single linked list node representation is just like struct node int data and struct node star next. Means we are using the structure from the C and C++ programming languages. So so here we are defining the two field, that is int data and int, sorry, and pointer of the next variable, or pointer of the next. Okay. Now this is an algorithm for the singly linked list in the C language. So as I've told you, the node representation, so it contains the two field, that is data and the next field. Means because of that particular node, struct node, it creates such kind of node. Just a minute. it creates such kind of node, means having the two field, that is data field and node field. Now this first line, the struct node star head, means it's create the node having the name like head, and also it's having the two field, that is data and next field. And these much means this struct node star 1 2 3 are means are also creating the next three nodes with naming as 1 2 3, and having means all are having the two field, that's data field and next field. Now after creating the nodes, we need to allocate the memory to each and every node. Okay, so by using this malloc function, we can allocate the memory for that particular node. Then we need to assign the value to each and every each and every node. So how we can assign? So we can assign by using this way, that is node name. After that, we need to just give the arrow and then equal to what value you have to assign. So here, for example purpose, I have given like one of data is equals to 1, means the node 1 having the data 1, same as follows, like node 2 having the data 2, node 3 having the data filled with the 3. After that, we need to connect the nodes with each other. As I've told you that the linked list is the non-contiguous, so means it's stored the non-contiguous manner. So we need to connect them. So for connecting purpose, we can means we are using this field, that is link field or next field. You can say that. So here one of next is equals to 2, means the 2 address, means the node 2 address is stored into this field. Okay, then node 3 address is stored into this field. Then node so in this field of node there will be null, because as I've told you that as it is the last node, so it requires the null into its next field or link field. And after that we need to save all these nodes, means means we need to link this first node with the head node for saving purpose or for getting the correct linked list from the memory purpose. Now, doubly linked list. So, doubly linked list, it contains the three fields, that is previous, data, and next. Okay, means as we add a pointer to the previous node in the doubly linked list, we can go in either forward direction or backward direction. Okay, so node representation of these particular doubly linked list is like in data, struct node next pointer and struct node previous pointer. So this is a doubly linked list algorithm, we can say that. So first of all, struct node head, means one head node is created. Um, okay, first head node is created having the field like previous node, then data node, and then next node. Okay, and then these three nodes are created, 1, 2, and 3, having the same field, that is previous, data node, and next node. After that, we allocate the memory for all of these. Then we assign the value, data value to this particular node. So here one data is assigned to this particular node, second value is assigned to this particular node, third value is assigned to this particular node. Okay, then we connect that particular node with each other, like the second node reference is stored into this next of first, then third reference is stored into the next of second, and the first reference is stored into the next of head. Okay, as of now, so we have done this part in our single linked list. But what is the new part here? The new part here is that the node also having the previous node detail, not only the next node detail. Okay, means the here the second node also having the detail of first node, means the first node detail also stored into this field. The second node detail is also stored into the previous field. Okay, so same kind of means work is happened here. That is the head node data is also stored into this previous node. So circular linked list is the variation of the linked list. So as of now, we are just declaring, means we are just putting the null over the next field of the last node. But here, the next field of the last node is connected again to the first node or again to the head node. So this is the variation of the linked list. In which the last element is linked to the first element, and this form is in the circular loop. So because of this, it means its name is that circular linked list. So actually circular linked list can be either single linked list or double linked list, as I have told you that for single linked list the next pointer of the last item points to the first item. Let me explain with the example. So as you can see here, means suppose there are two nodes and both are connecting with each other. The last node means the next pointer of the last node is connected to the head node. Okay, so this is the singly linked list, and in doubly linked list, the previous pointer of the first node, means this is the previous point. The previous pointer of the first node is connected to the last pointer of, means connect to the last pointer, as well as the next pointer of the last node is connected to the first node. Okay. So this is algorithm of the circular linked list. Here I have given the single linked list algorithm. So if you want the doubly linked list algorithm as well, so you can tell me at comment section. I'll be doing the video on that as well. So we can assume the these three nodes, and means actually it's working is same as the single linked list, but just different is that, like this link field or this next field is, means it's not filled up with a null, means it's contains some value, it's contains some reference, that is nothing but the head element reference. Okay, means only this part is different in this particular algorithm. In coming videos we'll complete the more operation on linked list, like insertion, deletion, etc. Then program on the linked list. Do subscribe and like, comment and share, and click on the bell icon for more update. For watching.